Alright, I cleaned up a little bit and now we're gonna try to find an expression for the margin. We will define two vectors, x plus, x minus, two vectors. And these vectors are on the positive side. So W transpose x plus b, and let's decide that it should be bigger than 1. And it's something that we set. And W transpose x minus plus b, we want to be smaller than minus 1. So all the points on this side minus 1, all the points on this side plus 1. Okay? And we also gonna draw these x plus and x minus vectors. I mean, they're closest to the hyperline, but they're like very, very, very close to the hyperline. Yeah. So on the negative side, I'll draw this one. Yeah. So this would be x minus, and let this vector be x plus. Okay? That means that this vector, let me put it in blue here. This blue vector here is actually x plus minus x minus, So the blue vector is x plus minus x minus. And what we would like to do is to have an idea on the width of that margin. Well, how do we get the width? Well, by projecting this blue vector to something that is perpendicular to that. Yeah? So remember, we had our unit vector here. W. If I project this vector to W, I have exactly the width. And when I call project, that means in math dot product. So you take the dot product of x plus minus x minus is this vector, and then I project it to the unit vector. And the unit vector I can write like this. Is the vector divided by its norm. We've seen that in linear algebra. X plus, x minus are here, but first I'm gonna define. The problem I have is I'd like to see one expression for this whole thing here. So I'm going to define set yi, and yi is either minus 1 or plus 1. Yeah? That's yi. So that means I can now say that yi times W transpose x plus b is greater or equal than 1. Yeah? Because when yi is positive, then you have exactly this equation. When yi is negative, then this changes and it becomes minus 1. Okay, and then in the gutter is this thing here. In the gutter, I'd like yi times W transpose x plus b equal to 0. Yeah? So in the gutter 0, on this side minus 1, and on this side of the gutter plus 1. Yeah? So now here, let me call this one number 1 and this one number 2. Number 1 is W transpose x plus bigger than 1 minus b. I brought the b to the other side. So x plus, I need to divide by w. Yeah? And then number 2, I have w transpose x minus is smaller than minus 1. Yeah? Smaller or equal than minus 1 minus b. So that means is minus 1 plus b. Okay, and that I divide by w as well. So if I now subtract, and this one disappears if I divide by w, if I subtract this one with this one, yeah, I have that x plus minus x minus equals is 1 minus b divided by w minus, this becomes then a plus, yeah, minus minus becomes a plus, yeah, 1 plus b divided by w, yeah, and then I multiply with w and then the norm. You see that this w, and this w disappear. Here you have minus b plus b, these disappear. So that equals to 2 divided by w. Yeah. I have to, of course, multiply with that. Okay, so we have an expression for our margin is 2 divided by the norm of w. So what we want to do with the margin, we want to maximize the margin. Yeah? So we want to maximize the margin, meaning we want to maximize 2 divided by the norm of w. Yeah? But that's the same thing as saying I want to maximize 1 divided by w. Yeah? It's the same thing. And that's the same thing as saying I want to minimize norm of w. So maximizing this means I flip the this here, so minimizing w, and that's the same thing as minimizing half of w squared.